were discussing chemistry of class 10th, and we were discussing chapter 9, that is of chemical equilibrium. And we have discussed the chapter till the end of dynamic equilibrium, and we'll be starting from the next topic, and that is of the graph, which is of dynamic equilibrium state. This, this graph is basically drawn between, just wait. Yeah, this graph is basically drawn between the two variables, that is the rate of the reaction, which is drawn on the y-axis, as you can see from the picture, and on the x-axis, it has taken time. So what does this graph show is that this graph shows the variation in between the forward reaction, rate of forward reaction, and the rate of reverse reaction. And what is a forward reaction and what is a reverse reaction? We have already discussed this in the previous section, but we'll go through it again in this class as well. So a forward reaction is what in which the reactants are being converted into the products, and reverse reaction is what in which the products recombine to make reactants. So if we talk about the rate of the reaction, of the forward reaction, at the very beginning, at the very start of the reaction, the forward reaction will be very fast. So that is why the rate of the forward reaction is at a very upper point, as you can see from here. Just wait. Yeah. Let me just use my pencil. Yeah. As you can see that this point, this shows the rate of the forward reaction, that the rate of the forward reaction at this point is very fast. Why? Because at the very start of the reaction, the reaction mixture has almost all of the reactants and none of the product is present at that time. So the rate of the forward reaction, the speed at which the reactants will react to form the products is very fast. But as soon as the reactants are being converted into the products, the amount of reactants is decreasing and the amount of products is increasing. So that is why the rate of the forward reaction decreases with the time. As the time passes on, the amount of reactants decreases. So that is why the rate of the forward reaction also decreases. On the contrary, if we look at the rate of the reverse reaction, at the very beginning, at the very start, the rate of the reverse reaction is 0. Why? Because at the very start of the reaction mixture has almost 0 products or negligible amount of products. But as soon as the reactants are being converted into products, as the time passes on, the products are being initiated and the products, or you can say that products are being made in the reaction. So as soon as the products are being made, and the amount of rate of reverse reaction will also goes towards the increasing point. Why? Because at the very start, both forward and reverse reaction are opposite to each other. If the rate of the forward reaction decreasing with time, the rate of the reverse reaction will increase with time. So as you can see from the graph, that the rate of the reverse reaction with time is increasing, and at a certain point, a stage reaches where both of these points coincides with each other. The point which I have marked on the graph. This point shows that the reaction mixture has attained an equilibrium state. What does this point means is, what does this line means is that at this point, the speed of the forward reaction, the speed at which the reactants are being converted into the products, will be equal to the speed at which the products are being converted into the reactants. So this is the position of the dynamic equilibrium state, as we have discussed it earlier. Let me just show you. As you can see in this, as you can see here that this is the condition for the dynamic equilibrium state, that the rate of the forward reaction and the rate of the reverse reaction should be equal, and this is the point of the graph where the rate of the forward and the reverse reaction is exactly equal to each other, and that hence we can say that the graph has attained the equilibrium state. There is no need to cram this whole paragraph. You just have to write it in your own words into the board exam. Let's move on to the next topic, that is the difference between the forward and the reverse reaction. It could come as a short question in your board exam. So let's just discuss it. So there are four characteristics that have given to you for the forward reaction and for the reverse reaction. First one is the forward reaction. It is a reaction in which the reactants react to form products. As I have discussed earlier in this lesson, that the reaction in which reactants are converted into products is known as forward reaction, and reverse reaction is exactly the opposite as the forward reaction, that the reaction in which the products are being converted to the reactants. And if we if we talk about the direction, the forward reaction has the direction of from left to right. Why? Because reactants, just wait, uh, the reactants are being converted into products. So you can see that the reactants are written on the left hand side and the products are on the right hand side. So the reaction direction is from left to right. But in case of reverse reaction, the products are converted into the reactants. So products is being converted into the reaction. Products are on the right hand side and the reactants are on the left hand side. So the direction of the reaction will be from right to left. And the uh, third point is that the rate of the forward reaction at initial stage is very fast, and the rate of the reverse reaction at the beginning is very slow, yeah, almost negligible, as you have seen in this graph. Like, just look at here. The rate of the forward reaction is very fast at the very beginning. This is the beginning point. The rate of the forward reaction is very fast, and the rate of the reverse reaction is almost negligible or zero. So this is what has said in the third. Final point is about it slows down gradually, as we have seen in the graph, and speeds up gradually, as you can see, also have seen in the graph. So let's move on towards the final topic. That is a very important long question, and it's a very easy long question. That is of some macroscopic characteristics of dynamic equilibrium. We'll discuss it, and we'll close this lesson for today. So first is a few important characteristics of dynamic equilibrium are given below. First one is an equilibrium is an equilibrium is achievable only in a closed system. As if you have listened my first lesson, then you must know that I have told you that there are two types of system. First one is open system and second one is closed system. And for equilibrium or for reversible reaction, we must have a closed system in which neither a substance can leave or neither we can add a substance. That is what a closed system is. And I have shown you a closed system and an open system as well. The second point, to moving on towards the second point, equilibrium state, a reaction does not stop. Why? Because it forms a cycle like this: reactants and products. Reactants are being converted into the products, and products are being converted into the reaction. So this becomes a cycle, and cycle moves on in a certain process. So that is why this reaction does not stop at equilibrium. Uh, yeah. Moving on towards the third point. At equilibrium state, the amount of the reactants and products does not change. Even physical properties like color density remains the constant. Yeah, this is a very important point. At equilibrium state, the amount or the of the concentration of reactants and products do not change. Like if the equilibrium has attained at, let's say this is the reactant and this is the product. Let's say we have said this, that the equilibrium has attained when the 40% of the reactants are being converted into the products. Let's say we have remained with the 40% of the reactants and 60% of the product. So this is the equilibrium stage. One thing is you should have clear in your mind that equilibrium doesn't mean that equilibrium of a reaction doesn't mean that there will be 50% of the reactants and 50% of the products. This doesn't mean this, because equilibrium is not dependable on concentration. It depends upon temperature. We will discuss this in the further lessons, next lessons. But from now on, you should know about that. The equilibrium does not depend upon concentration. So at any point, equilibrium can be established. So let's say we have 40% of the reactants and 60% of the product. So for this type of specific reaction, the amount of reactants, the 40%, and the amount of products, the 60%, will never ever change its concentration, or the physical properties like color density will also remain the same. So Now, towards the fourth point, an equilibrium state is attainable from either way, starting from the reactants or from the products. Like you can start it from the reactant side, or we can say that from the right side, left side, or we can start it from the right side. You can attain equilibrium from either way. And the final point is an equilibrium state can be disturbed and again achieved under the condition of the concentration, pressure, and temperature. This is the point that I was talking about, that if we have reactants and these reactants are being converted into the products, let's suppose this previous reaction that the equilibrium has attained when the 40% of the reactants are present and 60% of the products are. So what I do is I disturb the amount of the products. I withdraw some of the products, and it comes down as 30%, and I add some of the reactants over here. Let's suppose 70%. I make it a 70%. So what I do is I have disturbed the equilibrium. What does it mean by that? That the equilibrium is established at 40 and 60. But now I have disturbed the concentrations, yeah, disturbed the pressure or temperature of the reaction, that like I have added into the reactant side and withdrawn from the product side. So now the reaction will move towards the forward direction, like reactants will further react and produce products in order to attain the equilibrium. So this is what this point means is. You can understand this point by doing it on the from the product side as well. You can get the same answer. So I hope that's is a very easy topic, and you guys have cleared all the concepts for this topic. And for now on, and if you have any questions, you can ask me in the comment section, and I'll try to answer. But your test yourself exercises, I'll be discussing for these test yourself exercise at the end of the chapter for every chapter. So for now on, I'll not be discussing the test yourself exercise. I'll make a separate video for only the discussion of test yourself exercises. So that's it from my side. See you in the next video. Until then, take care and bye bye. Allah Hafiz.